trigonometric functions of an acute angle. The goal is to find the 6 trig ratios of a given angle. You'll also hear me call them functions. The 6 trig functions of an acute angle. And it is going to be an acute. What is an acute angle? An adorable little angle that's less than 90 degrees. That's an acute angle. That's goal number 1. Goal number 2 is to evaluate trig functions of special angles. 30, 45, and 60 degrees for now, for this section, will be the special angles. And goal number 3 will solve some of the classical applications of right triangle trigonometry. So first things first, we've got to define those 6 trig ratios. They're also called functions. The 6 trigonometric ratios, also known as functions of an angle. Functions have, remember, inputs and outputs associated with them. So you input a number, you get a specific output. You don't get 2 different outputs or 3 different outputs. You get 1 output for every input, and that's a function. So do you guys remember what a function is, what function notation is? So when I say y equals f of x, what comes to mind? Y equals f parentheses x. So y is some formula in terms of x, really, is what that notation means, right? I mean, f stands for function, but you can also think of it as standing for formula, where x is the input, or whatever letter is there stands for the input. It doesn't have to be x and y. X is the input, and y is the output. So a basic function that graphs to be a parabola is y equals x squared. You could call it f of x equals x squared. You can always replace y with f of x. Y is f of x. So if I picked an input of 2, remember, let's use 3. If I picked an input of 3, I would replace x with 3, and I would call this f of 3, and f of 3 would equal 3 squared, which is 9. So you guys know about the notation. Another representation for this input and of 3 and this output of 9 would be as an ordered pair, 3, 9, right? So 3, 9 is on the graph of y equals f of x. Okay, everybody knows about that. So the 6 trig ratios are also functions where we have inputs and outputs. So let me attempt to draw a little right triangle for you so that we can refer to this thing. There's the right angle. And I'm going to stick in an angle called denoted by a Greek letter, theta. And that's going to be the input. Theta, the angle, is going to be our input to our trig functions. The output's going to be a ratio. Okay, I'm going to label the opposite side of theta y, but we're also, in a minute, we're going to think of it as the opposite side, so I'll also label it OPP for opposite. In relation to theta, the side of length y is the opposite side, isn't it? And then I'm going to label the side right next, not the hypotenuse, but the other side right next to theta, I'm going to label that x. The way I've drawn it, it's horizontal, so it makes sense to label it x, right? And then right next to, what's the word for that? Adjacent, ADJ for adjacent. Then the hypotenuse, we usually label with an R, and that's HYP if you think of it in terms of hypotenuse. So the 6 trigonometric ratios, the first ratio we write down, let me write down the actual words, how to spell them, because sometimes we forget that the letters we use to stand for the function are short for the actual word that describes the function, the name of the function. So there's the sine function, there's cosine, there's tangent. All of these are functions. There's cotangent. There's secant. And cosecant. This is probably the only time in the class you'll see me write out the full spellings of these names. So the sine function is abbreviated. If you want to take the sine of theta, it's abbreviated like this, SIN, and then you put the angle right after that. The input comes right after the SIN. Sometimes some people like to put in parentheses here. Many algebra systems like WebAssign, when you punch in answers, might require parentheses there to make it look more like the function notation you're used to, like y equals f of theta, not this y not related to this y. And remember we have parentheses there. The input is theta, the output is y. But the convention is, when you write it by hand, to really, unless you really need it, to not put the parentheses in there. But keep in mind, sine is the name of the function and the input is theta. So the sine of theta in this case, theta is the input, the output turns out to be the opposite over the hypotenuse, which is y over r. Does that look familiar to you? We'll write down opposite over hypotenuse too, because some of you might think of it in those terms. Does that look more familiar to you? Yeah? Does anybody remember what the cosine of theta is? How that's defined? So that would be x over r, and then some of you said equivalently adjacent over hypotenuse. And then the tangent of theta, T-A-N for short, y over x, which is opposite over adjacent. So what's the mnemonic device for remembering those three trig functions? These are just definitions, right? These three trig ratios. Good old SOHCAHTOA. So SOHCAHTOA, it's spelled like this. Okay, that's the sine equals opposite over hypotenuse part, right? C-A-H, that's the cosine equals adjacent over hypotenuse part. And then TOA. That's tangent equals opposite over adjacent. Now there's three other trig functions we need to know about, but they just involve the reciprocals of the first three that we talked about. And so the order I write it in is, as I delineated here, the next one would be cotangent. Let me stick with my color scheme. Okay, cotangent of theta. Cotangent, it turns out cotangent is defined to be the reciprocal of the tangent. So if tangent's y over x, what's cotangent? X over y. And I'm not going to bother putting adjacent over opposite. And that, but it is true that cotangent's equal to flip this guy adjacent over opposite. And then secant of theta, SEC for short. Yeah, it does turn out to be the reciprocal of the cosine. I'll show you how to remember that in a second. R over x. And then cosecant, CSC. Turns out to be the reciprocal of the sine, which is what? R over y, right? R over y. Okay, so how do you remember what's what here? Well, this worked for me. You use whatever method works for you. When you write it in the order sine, cosine, tangent, cotangent, secant, cosecant, for whatever reason, I got in the habit of writing it, if I needed to write down all 6 trig functions, in that order. And if you write it in that order, there's an easy way to remember the reciprocal relationship. The outside guys are reciprocals, top and bottom guys, reciprocals of each other. And then from there on out, it's this guy and the furthest guy away from that hasn't already been indicated. So cosine theta and secant theta are reciprocals. And then these two inside guys are reciprocals as well. However you do it, make sure you remember those reciprocal relationships. Because if you remember the reciprocal relationships, you only need to define the first 3 trig functions and know those by heart. Okay? And to know those by heart, just know SOHCAHTOA, and and you'll have it.